Okay, let's have a look at the solution to assignment 5 of chapter 15. Question 1, solve this inequality. Okay, so apparently this is a product of several binomials, right? Product of several binomials is actually a polynomial function. So in order to solve the inequality, first we check the degree of this polynomial function. Okay, first of all, the degree. You can simply find how many x's are there. So 1, 2, 3, right? Product of 3 x's. Therefore, the highest possible order is 3. Therefore, the degree is 3, right? And of course, 3 is a odd number. Okay, next we find its leading coefficient. Okay, leading coefficient, there is a shortcut to find the leading coefficient. It's simply the product of all the leading coefficient of each of the binomial here. So we have 1, then times the leading coefficient here, which is -1. Then the leading coefficient here is another -1. So apparently this is a 1, which is greater than 0, right? And according to the table I gave you last time, if you have a leading degree is an odd number and the leading coefficient is a positive number, then the end behavior is known to us, right? End behavior will look like this. Okay, next, we need to sketch the behavior in the middle. So that depends on the zeros and their orders. Then let's find zeros and their orders. Okay, first of all, if you let the function on the left side be 0, apparently there are 3 zeros, right? Either x is -2 with order 1, because there is only one such term. The order here is 1, 1, 1, 1. So next 0 is 3, also with order 1. Next is 4, also with order 1. And of course, if you have a 0 with order 1, you don't have to write here explicitly, because by default, if you don't write anything by default, we consider 0 with a order 1, right? Okay, so now we can sketch the graph of this polynomial function. So this is a horizontal axis. First of all, we know that this function has a end behavior like this, right? And then the 3 zeros. First is -2, then 3, then 4, right? So this function will go all the way from -infinity to the first 0 here. Then at the first 0, we need to decide whether it goes this way or this way. We need to check the order at this 0, right? Order 1 is apparently a odd number, right? And at each 0 with odd number order, we need to change the sign before and after the 0 here, right? So this sign of this function will change from negative to positive. So it will cross this point here. Then it will go back to the next 0, -3, +3 here. Also, this 0 has order 1. 1 is an odd number. So that means this function will change sign from positive to negative. Then it will go all the way to the next 0 here. Next 0 has order 1. 1 is odd number as well. So this function will change sign from positive to from negative to positive, then it will connect to the end behavior as x approaches positive infinity. So basically, this function will have a sketch like this, right? Can you follow me?
Yeah.
Okay. And remember that we're going to find this any interval that makes this function greater than or equal to 0. Okay, so according to the sketch, equal to 0, and greater than 0 is here. Equal to 0 and greater to 0. Therefore, there are two intervals that can make this function greater than or equal to 0. Therefore, we can say the solution is x is either within -2 and 3 inclusive, or x can also be greater than or equal to 4, right? Okay, please have a look at this question and let me know if you finish, okay?
All right.
All right, next one. Solve the inequality, okay? By observations, this is another product of several binomials, right? Again, this is a polynomial function. So first of all, let's consider the function on the left. Y equals 2x minus 1 to the power of 2, 3 minus x to the power of 4, then x plus 4, then x minus 5, less than 0. Okay, first of all, if we consider this function here, apparently this is a polynomial function, right? And first of all, we can find its degree, which is the highest possible order of x. So here we have 2x, 4x, 1, and 1. So the degree is just 2 plus 4 plus 1 plus 1, which is 8, right? And 8 is a even number. Next, let's consider the leading coefficient. A leading coefficient, okay, is simply the leading coefficient of each of the factor. So for the first one, we have 2x minus 1 squared. So we need to consider 2 squared, right? Next one multiplied by, next one is -1, but we have to the power of 4. So to the power of 4, then multiplied by next one, leading coefficient is just 1 to the power of 1. Then last factor has a leading coefficient of 1. So apparently 2 squared times -1 to the power of 4 times 1 is a positive number, right? So by first glance, according to the table, we know end behavior now, right? Degree is an even number, leading coefficient is positive, so the end behavior of this function will look like this, right? And then we need to decide its behavior in the middle. That depends on the zeros and their orders, right? Then let's find its zeros and their orders. Okay, to find zeros, we can simply let this function be 0 and find all the solutions, right? So if y is 0, of course, x can be 1/2 with order 2, right? Because we have a power to the power of 2 here. So the first 0, x equals 1/2 has a order 2. Next, we have x equals 3, right? With order 4, because here it says to the power of 4. So that means we have a order 4 for this 0. Next, we have x equals -4. And there is a power to the power of only 1, so x equals -4 with order 1. We don't have to write anything here. And last, x minus 5, also the 0 is x equals 5 with order 1. Okay, now we can sketch graph of this polynomial function. First of all, and behavior look like this. And then let's mark all the zeros. First one is -4. Next one is 1/2. The next one is 3. Last one is 5, right? Then this function, let's go from left to right. This function as approaches to the first 0 here, we need to check whether it will go this way or this way, right? That depends on the order at this 0. So note here, x equals -4 here with order 1. 1 is odd number. Odd number does not change the sign, right? Sorry, odd number order does change the sign of this function. So this function will go from positive to negative. So it will cross this point. Then go to the next 0 here. Next 0 is 1/2 with order 2. Order 2 is an even number, so it does not change sign. So it will bounce back. Does not change sign, right? Before this point, it's negative. After this point, it's still negative, right? Okay, then goes to the next 0, 3. 3 with order 4, again, 4 is an even number, so at this 0, it does not change sign. Before this point, it is negative. After this point, it's still negative, so it bounces back again. And to the next 0, which is 5. 5 with order 1. 1 is an odd number, so it will change sign. That is from negative to positive. And then it connects to its end behavior as x approaches to positive infinity. So basically, it will have a shape like this, right? And remember that our task is to find any intervals that makes this function less than 0. Okay, then let's find such intervals. Of course, any of the zeros cannot be included because at this point, simply will make this function be 0, not less than 0. So first interval that makes this function less than 0 is from -4 to 1/2. Next one is 1/2 to 3. And the next one is 3 to 5. So there are 3 possible intervals that can make this function less than 0. That is, x can either greater than -4, less than 1/2, or x can also be greater than 1/2, less than 3, or x can also be greater than 3 and less than 5. So the solution is 3 intervals. Okay, please have a look at this question and let me know if you finish, okay?
Okay.
All right, next one. Okay, solve the inequality here. Okay, so there are several factors, right? And apparently the first factor is not factored totally. So let's try if we can factor this further, okay? So first of all, let's try using cross multiplication method. So -4x can be factored to, let's try 2x by -2x. Then -3 here. So let's try put a 3 here and -1 here. And by cross multiplication, this will not do it. So it doesn't work. So let's try, how about x and -4x. Okay, doesn't do either. So possibly cross multiplication is not a good idea. So let's try to convert it to the vertex form then. We can try using, okay, so let's call this asterisk. Then this is equivalent to, if you put the negative symbol in front, then what's left in the parentheses is 4x squared plus 4x, then plus 3, right? And then we can multiply -1 to both sides. So it is equivalent to this one. The reason I want to remove the negative symbol is we can make this problem simpler without the negative leading coefficient. So let's try to write this first expression in a vertex form. So we can try using 2x plus 2 squared, right? If we expand it, you will get 4x squared plus, sorry, we should put a 1 here. If you expand it, you will get 4x squared plus 4x plus 1. So the first two terms should be exactly the same with first two terms, but there is no plus 1, so we need to subtract it, and then plus 3, which is actually plus 2, right? And then times x minus 3 squared, then x plus 4 less than 0, right? Then let's study the first factor here. So 2x plus 1 squared is a non-negative number, right? So it's always greater than or equal to 0. Then if we plus a 2, this expression is always positive, right? Can you follow me?
Yeah.
Okay, so if it is a positive number, we can divide this number for both sides of the inequality. Does not change the solution, right? So we can divide this positive number here. So this inequality is equivalent to x minus 3 squared plus multiplied by x plus 4 must be less than 0. You understand?
Yeah.
Okay, so that means we successfully simplified the original inequality to this one. This inequality looks much simpler, right? Then we consider the function on the left. We can consider y equals x minus 3 squared, then times x plus 4, right? The degree is highest possible order is 3, right? Because there are x, 3 axis multiplication. So degree is 3, which is an odd number. Then let's consider the leading coefficient. Leading coefficient of first factor is 1 to the power of 2. Then next is just 1, which is a positive number, right? That means its end behavior will look like this. And then we need to study the behavior in the middle. That depends on the zeros and their orders. Okay, so in order to find zeros, we let y be 0. Apparently, the first 0 is x equals 3 with order 2, right? Because it says to the power of 2 here. Then next 0 is x equals -4. Apparently, the order is 1, right? Okay, then we can sketch the function as follows. First of all, and behavior look like this. And then there are two zeros. One of them is -4. The other one is 3. Okay, so as x goes from -infinity to the first zero here, so then we need to check the order of -4. Order is 1, which is odd number. Odd number, the function will change sign from negative to positive, right? Then goes all the way to the next zero. Next zero has order 2. So the function does not change sign. So before this point is 0. After this point, also before this point it is positive. Then after this point, it should be positive. So it bounces back. So all the way to positive infinity as x approaches to positive infinity, right? So basically, this is the sketch of this function. And remember that our task is to find, this is our task, right? Our task is to find any interval that makes this function less than 0. So less than 0 is this interval. And this is the only interval that can make this function less than 0, right?
Mhm.
Okay. Therefore, x should be less than -4. Any questions?
No.
Okay, so let's see the next one. Okay, next one. It's a product of two polynomials. So first of all, let's check if we can factor them further. So for the first one, it's not difficult to see that we can use cross multiplication, right? 3x squared can be factored x and 3x. The -2, let's put -2. Okay, let's put 2 here and -1 here. By cross multiplication, we'll get -3x plus 2x. And this is -x, which is exactly the same with -x in the middle. So the first polynomial can be factored to x minus 1, then 3x plus 2, right? How about the next one? Next one, let's try 20 is 4 by 5, and sum of 4 and 5 is 9. So probably we can use cross multiplication. So let's check. -x squared can be factored to x by -x. Then let's put -4 here and then 5 here. -4 by 5 is -20. And then by cross multiplication, we'll get 4x plus 5x, which is 9x, which is a term in the middle. So this is equivalent. And luckily, we can factor both of them, right? Second expression can be factored to x minus 4, then minus x plus 5, right? And less than or equal to 0. Okay. And now we have a product of 4 binomials. Then we can consider the function on the left, which is x minus 1 times 3x plus 2 times x minus 4, then minus x plus 5. Use the same method, right? And then find its degree. Degree is the highest possible order of x. So let's count how many x's are there. 1, 2, 3, 4, right? So degree is 4. 4 is a even number. And leading coefficient. Leading coefficient is the product of all the leading coefficients, right? 1 by 3 by 1 by -1. And apparently this is less than 0, right? And we know that if degree is an even number, leading coefficient is negative, then its end behavior will look like this, right? And then we'll study its behavior in the middle, which depends on the zeros and their orders. Then let's find its zeros and their orders. Okay, so if we let y be 0, apparently x can be 1 with order 1, right? Or x can also be -2/3 with order 1, right? X can also be 4 with order 1. And last, x can also be 5 with order 1, right? Can you follow me?
Yeah.
Okay. Then based on this information, we can sketch its graph. Sketch the graph of this function here, right? Okay, so end behavior will look like this. And there are 4 zeros. First one, -2/3. Next one is 1. Next one is 4. Last one is 5. 5 is the largest one, right? Okay, so as x increases from -infinity to the first 0 here, you need to check the order at this 0, right? Note here, all of the zeros have order 1. That means all of them has a odd number order. So at a odd number order, the sign of this function should change, right? That means we'll cross this point here, then go to the next 0, also change sign from positive to negative. Then to the next 0, also change sign, this time from negative to positive. Then to the last 0, also change sign, this time from positive to negative. Then all the way go to the negative infinity as x increases to positive infinity. Okay, and then our task is to find any interval that can make this function less than or equal to 0, right? So less than or equal to 0 means this interval here, or this interval in the middle, and this interval here, right? Therefore, there are 3 intervals. Solutions are x is either less than or equal to -2/3, or x can also be within 1 and 4 inclusive, or x can also be greater than or equal to 5. This is our solution. All right, please have a look at this question and let me know if you finish, okay?
Okay.
All right, next one. Okay, next one, we have a product of several polynomials, right? And let's try if we can further simplify any of them. So for the first one, we can factor this, right? Note here, we have a formula states that a cubed minus b cubed is just a plus b times a squared minus ab plus b squared, right? You can use this formula to further factor the first expression. Can you follow me?
Yeah.
You remember this formula? And
Yeah.
the other similar formula states that if you have a sum of 2 cubes, this, oh, sorry, my mistake. If you have a negative symbol here, this should be negative, then this should be positive. Then if you have a sum of 2 cubes here, then this can be factored to a plus b, then times a squared minus ab plus b squared, right? We can use these formulas to factor a expression like this. So apparently 8 times x cubed is just 2x cubed, right? Minus 27. 27 is 3 cubed, right? And if you have a difference between 2 cubed, apparently this is 2x minus 3, and then 4x squared plus 6x plus 9, right? So this is the factoring result of the first expression. So let's say the original expression, original inequality is equivalent to this one. 2x minus 3 times 4x squared plus 6x plus 9, right? Then 2x plus 3 cubed greater than 0. Okay, next, let's check. It seems that this expression is always greater than 0. Why? Because if you consider converting it to a vertex form, this is actually 2x plus 3 squared, right? If you expand it, you will get 4x squared plus, sorry, my bad, you should use 3 over 2, right? If you expand it, you will get 4x squared plus 3x plus 9 over 4. Because there is no, sorry, let me check. Yes, this should be 6, not 3. And there is no 9 over 4, so let's subtract it. So this expression is exactly the same with the first two terms, right? Then let's copy the plus 9. So this one is exactly the same with this one, right? And this is actually 2x plus 3 over 2 squared, and then plus a positive number, right? Can you follow me?
Yeah.
So this number is a non-negative number because something squared is always greater than or equal to 0, right? Then if you plus a positive number, then the whole expression here must be a positive number. Do you understand? Can you follow me?
Yeah.
All right, so let's write it here. As we have analyzed, this is equivalent to 2x minus 3 times, okay, 2x plus 3 over 2 squared plus 27 over 4 times 2x plus 3 cubed greater than 0, right? Okay, let's say this is number 1, because 2x plus 3 over 2 squared, this is non-negative, right? Plus 27 over 4 must be a positive number, right? Then we can actually divide both sides using this positive number. Therefore, a is actually equivalent to this one. Do you understand?
Yeah.
All right. Remember that only if you can decide this number is always positive, you can divide it in both sides, right? Otherwise, you cannot do this. Okay, next we can consider the function on the left. Consider y equals 2x minus 3. Our task is to find the solution to this inequality, right? Well, let's consider the function here. First of all, the degree. So highest possible order is 1, 2, 3, 4, 5, right? Which is even. How about the leading coefficient? Leading coefficient is, first leading coefficient is 2 times next one is 2 to the power of 3, which is a positive number. So basically, the sketch of the end behavior will look like this. If you have an even number degree and the leading coefficient is positive, so basically the end behavior will look like this, right? Then we need to analyze its behavior in the middle. Then let's find its zeros and orders. Okay, let me clarify. You don't have to write these, right? This is only for you to understand. Of course, in your solution, you don't have to write these. You can only write the final sketch of the graph. Zeros and orders. So if we let y be 0 here, it's easy to see that first 0 is 3 over 2 with order 1, right? And the other 0 is x equals negative 3 over 2 with order 3, right? Because here you have a power 3. Understand?
Yeah.
Okay, then we can sketch its graph. So first of all, the end behavior look like this. And one of them is 3 over 2. The other 0 is positive 3 over 2. Then as x approaches from negative infinity to the first 0 here, first 0 has a order 3. So order 3, it must change sign, right? That means from positive to negative. Then to the next 0 here, next 0 has order 1. Order 1 is also an odd number, so it will change sign from negative to positive. So basically, this is a sketch of this function, right? And our task is to find any interval that makes this function greater than 0. And apparently, anything that is to the left of the first 0 can make this function greater than 0. Or anything that to the right of the second 0 can make this function greater than 0. Therefore, the solution is x is either less than negative 3 over 2 or x is greater than 3 over 2. This is our function. This is our solution. Okay, please have a look at this question and let me know if you finish. And as you can see here, the key is to draw the correct sketch, okay?
Okay.
All right, then let's have a look at the next one. All right, next one seems that we can, factor this or this, right? If we can't, then we can considering converting them to the vertex form, right? So let's try the cross multiplication first. Okay, first expression, let's try, how about 3x minus 1 squared? 3x minus 1 squared, if you expand it, you will get 9x squared minus 6x plus 1. Okay, it's exactly the same with the expression here, right? So basically it can be factored to 3x minus 1 squared. How about the next one? Next one, let's consider 2x squared can be factored to x and a 2x. Then we have a negative 2 here. So probably let's put 2 by 1 here. and 2 by -1 will get you -2, and then by cross multiplication we'll get 4x minus x is 3x. That won't work because we have -3x here. So probably you will put negative symbol here and a positive symbol here. Then by cross multiplication, this time we'll get minus 4x plus x, which is -3x, which is the term in the middle. Okay, so that means second expression can be factored to x minus 2 times 2x plus 1, right? Okay, so basically let's call the original expression asterisk. So original expression is equivalent to 3x minus 1 squared. Then, okay, this process should be done in a scratch paper. Then times x minus 2 times 2x plus 1, then times 4 minus x, right? And then copy the rest of the inequality. Which is less than or equal to 0, right? Okay, now the left side is a product of several binomials. Then let's consider the function on the left. Consider y equals 3x minus 1 squared, x minus 2, 2x plus 1, then 4 minus x. First of all, let's find its degree. What is the degree? So 2x, 3, 4, 5. Degree is 5, right? So degree is a odd number. Next, how about the leading coefficient? Leading coefficient is 3 squared times 1 times 2 times a -1. That means it must be a negative number, right? So odd number degree and negative number leading coefficient will give us a end behavior like this, right? Then analyze the behavior in the middle according to the zeros and their orders. Okay, zeros and their orders. Okay, first of all, if you let y be 0, we can have x be 1/3 with order 2, right? Because we have a power 2 here. And next 0 is x can be 2, right? And next one, x can also be -1/2. Last one, x can also be 4. All of these 3 zeros have orders 1, right? Can you follow me?
Yeah.
Okay, then based on this information, we can sketch its graph. First of all, the behavior, the end behavior look like this, right? We have -1/2, then 1/3, then 2, then 4. 4 zeros, right? And then we go from left to right. As x approaches from -infinity to the first 0, let's check the order of the first 0, -1/2. Order 1, so that means the function should change sign. That means from positive before this point to negative after this point. Then to the next 0, 1/3. With order 2, order 2 means this function does not change sign here. That means before this point is negative, after this point is still negative, so it bounces back. Then to the next 0, 2, with order 1. 1 is odd number, so this function will change sign from negative before this point to positive after this point. Then to the next 0, 4, which means 4 has an order 1, which is a odd number, which means this function needs to change symbol, change sign at this point, from positive for this point to negative after this point, right? Okay, and remember that our task is to find any interval that makes this function on the left be less than or equal to 0. Apparently this interval will do. This interval will also do, and this interval will also do, right? Therefore, the solutions are x is either greater than or equal to -1/2 or less than or equal to 2, right? This is first interval. Or the next interval is x can also be greater than or equal to 4. All right, please have a look at this question and let me know if you finish.
Okay.
All right, then let's see the next one. Find all values of k such that the solution of the inequality here is consists of only one single interval, possibly infinite on the number line. Okay, in order to find such values of k, we can just try to solve this inequality, right? Apparently, the function on the left is a product of several binomials, which is a polynomial function. So first of all, let's consider the function on the left. Okay, you should say consider the function y equals expression on the left, because everything is factored. Therefore, we don't need to do any factoring process, right? We should consider its degree. So what is the degree here? How many x's are there? 1, 2, 3, 4, right? So degree is just 4, which is a even number, right? How about the leading coefficient? Leading coefficient is -1 times 1 squared times 1, right? Which is a negative number. So based on the degree and leading coefficient, we know the end behavior of this function will look like this, right? Can you follow me?
Yeah.
As to the behavior in the middle, that depends on the zeros and their orders. So let's find the zeros and their orders. And if we let y be 0 to find the zeros, apparently one of them is x equals 1 with order 1, right? Next one is x can be 2 with order 2, right? And next one can be x equals k with order 1, right? And don't have to write all the one here. And based on this information, we can sketch the function, right? But you know that when we label the zeros, 1, 2, are easy to determine the relative positions. But how about k? K can be here, right? Which is can also be here, can also be here, can also be here, or can also be here, right? There are 5 different situations. That means we need to discuss possible values of k besides their relative positions. Okay, first case is if k is the smallest, which means k is less than 1, what will happen? Okay, if k is less than 1, this is k, right? And this is our 1, this is our 2, right? If k is less than 1, end behavior always look like this, right? So as x approaches k from negative infinity, apparently k has all the 1, 1 is odd number, so this function will change sign from negative to positive. The next x equals 1 with all the 1, 1 is odd number, so this function again will change sign. Then we'll go to the next 0, 2, 2 has all the 2, so this function will not change sign, so it bounces back, right? This is a sketch of this function if k is less than 1. Can you follow me?
Yeah.
Okay, let's see the second case. Second case, k can be exactly 1, right? Okay, if k is 1, then actually k and 1 is the same point, right? 1 is k, k is 1. And next point is 2. And we know the end behavior always look like this, right? So as x goes to the first 0 here, now x equals 1 or x equals 2 equals k has appeared twice. That means it has order of 2 now, right? Order 2 is a even number. So that means this function will not change sign. So that means it will bounce back from negative to negative, right? Then we'll go to the next 0, 2 here, which also has order 2. Therefore, it does not change sign either. So it will bounce back. Then this is a sketch of this function, right? Okay, third case, if k is within 1 and 2, this function will look like this. 1 is here, k is here, and 2 is here, right? And end behavior is still the same. And then x approaches to the first 0, 1, has order 1, so that means this function will change sign. Then to the next 0, order 1, change sign. Next 0, order 2 does not change sign, so we'll go this way, right? Can you follow me?
Yeah.
Okay, then fourth case, if k is exactly 2. So as k increases, k can also be exactly 2, right? If it is exactly 2, this is 1, this is 2, 2 is also k, right? That means this function will go this way. First 0 has order 1, so it will change symbol here, right? And goes to the next 0, which is 2. 2 happens twice, and x equals 2 happens once. That means in this case, x equals 2 occurs 3 times, which means it has an order 3 now, right? Not 2, but 3. So that means this function will change symbol, will change sign from positive to negative, right? Okay, so in this case, this function will look like this. And the next case, if k is the largest, that means if k is greater than 2, the right positions of these 3 zeros will be 1, 2, and then k, right? And end behavior still looks the same. because leading coefficient degree does not change, right? So as x approaches to the first zero, x equals 1 has order 1, so this function will change sign. The next zero, order 2 does not change sign. Next zero k with order 1, so it will change sign from positive to negative. So in this case, this function will look like this. Okay, there is no other cases. These are the only 5 possible cases that k can be, right? Okay, our question is that for what values of k, the solution consists of only one single interval. Okay, so remember that our solution is any interval that makes this function on the left greater than or equal to 0. So let's consider the solution in the first case. Greater than or equal to 0, apparently this interval can make it greater than or equal to 0. And as well as this point, right? And for the second case, apparently this point won't make this expression greater than or equal to 0, right? In the third case, the interval is here. Greater than 0, greater than 0. Fourth case, greater than or equal to 0 is this interval here. Last case, greater than or equal to 0 means from this point all the way to here, and then all the way to here, right? And as you can see here, if the solution contains only one single interval, that corresponds to case 4 and 5, right? Therefore, k can be exactly 2 or k can also be greater than 2. Of course, we can combine these two cases to say that k can be any number that is equal to or greater than 2. This is our final solution. Okay, have a look at this and let me know if you're finished. Okay.
Okay.
Right, then let's have a look at the last one. Solve this inequality. Okay, what's the difference between this question and all the questions previously discussed? In this question, we have a ratio, right? We haven't discussed any problem that involves ratios. Therefore, you should think of that if you can convert this expression into a product, right? We have discussed a lot of questions involving product rather than ratios. So basically, if you have 3 numbers A, B, and C, product of A, B, and over C is greater than 0, is it equivalent to say the product of these 3 numbers is greater than 0? Are these two expressions equivalent? Are they equivalent?
No, no,
Why?
because
Okay, actually the ratio between these two numbers only depends on the positive or negative symbol in front of them, right? For example, if I tell you 2 by 3 over 6, this is greater than 0, right? Of course, 2 by 3 by 6 also greater than 0, right? So if we have 3 numbers, or let's discuss this way. So we have 3 numbers, A, B, and C, right? let's say, how many cases are there? First of all, we can have them all positive, right? So let's check the signs. Next case is plus plus negative, then plus negative plus minus plus plus minus minus, then minus plus plus minus plus minus 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 plus minus minus minus. There are only 8 cases, right? Do you understand? If we only consider the sign in front of each number, there are only 3 cases. Do you understand? Can you follow me?
Yeah.
Okay, so for each of the case, let's consider the sign in front of AB over C and ABC to see whether they are the same. So if all of them are positive, AB over C must be positive, right? You understand?
Yeah.
How about ABC? ABC is also positive, right? You understand? Positive number times a positive number over a positive number must be positive, right?
Yeah.
Okay, so how about the second case? Positive number times positive number over a negative number. This is negative, right?
Yeah.
So how about AB times C?
Negative.
Negatives. How about the next case?
Negative.
Negative, negative. How about next case?
Positive.
Positive. Positive, right? Next one.
Negative. Positive. Positive. Negative.
Negative, right? So as you can see here, the sign in front of AB over C and sign in front of AB times C are actually the same in each of the case, right? Either of them only depends on the number of the negative symbol that appears, right? Do you understand?
Yeah.
So no matter A, B, and C is, as long as the denominator is not 0, actually the product of the two numbers, if you don't use A and B, the product, the ratio between these two numbers, if this is a positive number, how about this one? That means the product of these two numbers also greater than 0. Are these the same thing? Are these the same thing? All right.
Yes.
Do you know the reason? If you don't consider 3 numbers, let's only consider 2 numbers, m and n. M over n and m times n. There are only 4 cases, right? Positive, 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 negative, negative, positive, negative, negative, right? If all of them are positive, then the ratio is positive. Of course, the product is also positive, right? And if any one of them is negative, then the ratio is negative. And the product is also negative, right? And if all of them are negative, the ratio is positive. And the product is also positive. Understand? So that means no matter what m and n is, m over n has the same sign with the product of mn. You understand?
Yeah.
Then you can treat a times b as a number. This is our m, this is our n, right? Therefore, AB over C greater than 0 is actually equivalent to AB times C greater than 0. You understand?
Yeah.
Okay, so based on our discussion here, we can say that the original expression, let's call this asterisk, original expression is actually equivalent to the product of the numerator and denominator is greater than 0, right? Because any one of them cannot be 0. Therefore, the ratio between these two numbers is greater than 0, is equivalent to the product of these two numbers is greater than 0. Do you understand?
Yeah.
Okay, that means we converted the original expression to a question that we have known how to solve, right? We can just consider the function on the left, which is y equals x plus 3, 1 minus x, then x minus 5. Apparently, this is a product of several binomials. So first of all, we find this degree. 1, 2, 3, 3x's, so degree is 3, which is an odd number. Then what is the leading coefficient? Leading coefficient is simply the product of all the leading coefficients. So 1 times minus 1 times 1, which is a negative number, right? Negative number. And odd number degree, which gives us the end behavior will look like this, right? Then we analyze behavior in the middle according to the zeros and their orders. Okay, zeros and their orders. Okay, if we let y be 0, apparently there are 3 solutions. One of them is x equals -3 with order 1. Next one is x equals 1 with order 1. Next one is x equals 5 with order 1 as well. All of the zeros have order 1. So based on this information, we can sketch the graph x here and -3, 1, and 5. Okay, first of all, any behavior look like this, right? And as x approaches to the first zero has order 1, so it will change symbol. It will change sign from positive to negative. Then cross the next 0, also change sign. Then cross the next 0 here, also change sign. So this is a sketch of such a function y here, right? And our task is to find any interval that makes y be greater than 0, right? And apparently anything here or here can fulfill this requirement, right? Therefore, the solution is x is either less than -3 or x is greater than 1 or less than 5. All right, have a look at this question and let me know if you finish, okay?
Okay.
Okay, so based on your feedback, I think we should do similar questions again. I'll upload the new assignment to Google Classroom. Remember to download it after the class, probably early tomorrow, okay? And also I'll upload the lecture notes for of today to Google Classroom as well. If you still don't know how to solve either any of them, you can always refer to my lecture notes, okay?
Yeah. Okay.
If you don't have any questions, I'll see you next time. Have a good evening. Bye.
All right. Thank you.